Most important topic in this chapter is solenoid and toroid. See, solenoid and toroid meeda previous year questions, there are many problems. The most easiest topic this is. Chala easy chapter, chala easy topic. Just here now. What is the meaning of a solenoid? See, solenoid means this type of a wire is wound like this. Okay, a wire is wound like this. Okay, so this is a wire. Now let us see what's going to happen now. Now, see here, this is a solenoid. So, the upper part will get a cylindrical shape. The wire is wound. Okay. So, how many turns are there? Number of turns is taken as n here. Okay. Number of turns here is n, and the length of the solenoid is taken as L. Okay. So, you have to find out the magnetic induction at the middle of a solenoid. What is the magnetic induction at the middle of a solenoid? How to find out that one? Let us see. So here, if you take this as a center here now, and if you draw the lines from this end to here, and from this end to here, and if you draw a middle line here, like this, a middle line, so how it is going to be? This is just like this is angle theta 1 and this is angle theta 2. See, like this, angles are theta 1. This is having a limited length, okay? So this is called as a finite length. Limited length solenoid is there. Then what is the formula to find out the magnetic induction at this point in the middle of a solenoid? It is going to be mu naught Ni by 2 sine theta 1 plus sine theta 2. This is the formula. Okay, so mu naught Ni by 2 sine theta 1 plus sine theta 2. What is this n? N means what is n here? N is nothing but number of turns per unit length. Total number of turns, small n is taken as total number of turns by the length of a solenoid is taken as small n here, is it? So this is one formula. The second formula is this is mu naught Ni by 2 into L, okay, because small n I am writing as capital N by L, and this is going to be sine theta 1 plus sine theta 2 is going to be our formula. This is for a finite length solenoid, okay, channel limited length, finite length solenoid. This is the formula here. So if you take an infinite length solenoid, what is going to happen? Infinite length means these terms are extending to the infinite lengths, right side and left side, infinity is there. So this angle theta will increase, both the angles will increase and becomes straight like this. And therefore, for infinitely long wire, if you consider, we will write this as mu naught Ni, first formula. Okay, the first formula is mu naught Ni by 2 sine 90 plus sine 90. For which type of solenoid? Infinite solenoid, infinitely long solenoid. So sine 90 plus sine 90 means 1 plus 1 is 2. So this 2 and this 2 gets cancelled. So for infinitely long solenoid, your formula is mu naught Ni. Okay, so where small n is nothing but capital N by L. Therefore, B for infinitely long wire can also be written as mu naught Ni by L. That's it. Okay, so these are the two formulas which you have to remember for infinitely long solenoid. For a finite solenoid, this is going to be the formula. Okay, if you take small n, it is a formula. And if you take capital N, this is a formula. And see, yesterday we have said about infinitely long wire, thetas will increase and increase, become the 90 degrees. So like this is a solenoid. Next thing is, what is the meaning of a toroid? Okay, so what is the meaning of a toroid? Okay, for solenoid, if you bend in the form of a circle, it's going to be a toroid. Okay, so here this is the current passing through this toroid, and the current is coming out like this. The current is coming out like this. Then what's going to happen now? A current is passing through the toroid. What is the magnetic induction in the middle of the toroid whose radius is r? whose radius of this toroid is r. So for that, what is the magnetic induction B? Here also mu naught Ni only, same thing, but here B is equal to, what is N? N means capital N by L, no? General formula. Small n is number of turns per unit length, but here length is going to be a circumference, capital N by 2 pi r. Total length is going to become a circumference here. So for a toroid, n is nothing but n into I by 2 pi r is going to be the formula for a toroid. That's a simple formula which you have to remember here. Understand? Is it okay? Is it okay? So see here, next, for a solenoid, if you are going to consider a solenoid, and I said that in the middle of a solenoid, if you want to find out a B, so this is a line, this is one line, this is one line, this is taken as angle theta 1, this is taken as angle theta 2. I told the formula just now. What is the formula? B at the center of a solenoid, and that to finite solenoid, the formula is mu naught Ni by 2 sine theta 1 plus sine theta 2 is a formula. But what happens to the toroid at the edge? At the edge, not in the middle, at the edge, what happens? See, at the edge means you have to consider the line like this, and another line is like this, and this is going to be theta 2, which is theta, and theta 1 is going to be 0. This side no angle, no, from here. Okay, so magnetic field at the center means this is the formula. Magnetic field at the edge, what is the formula for magnetic field at the edge of a solenoid? Same formula, little bit modified. What is the formula for magnetic induction at the edge? Mu naught Ni by 2 sine theta 1 is sine 0 and sine theta 2 is sine theta. Sine theta 2 is sine theta. Because theta 2 I am taking only one angle. No, why theta 1, theta 2? Only simple theta we can take. It is starting from this side, so this side no angle, 0. The formula will change like this. B at the edge is going to be how much? It's going to be mu naught Ni by 2 sine theta. That's it. Sine theta. Okay. Sometimes he will give you sine theta means what is that? We have to find out. Opposite side of the hypotenuse you should know. Okay. But here this is for a finite wire. Okay. This is the formula for a finite wire. If it is an infinite solenoid, okay, like this, it is continuing up to infinity. Then what happens to this formula? B at the edge. This is for a finite, and for infinite, what is the formula? For infinite, what is the formula? Mu naught Ni by 2 sine 0 plus sine 90. This angle opens and becomes straight. It becomes 90 degrees. Is it okay? I am saying. So therefore, sine 0 is 0, sine 90 is 1. So B for infinitely long wire at the edge, the formula is mu naught Ni by 2. Okay, or B at the edge for infinitely long wire is taken as mu naught Ni by 2 into L. Okay, middle means mu naught Ni, edge means half of the mu naught Ni. Middle means mu naught Ni, edge means mu naught Ni by 2. For infinitely long wire, long solenoid. Understood? This is a complete story of a solenoid. Okay, this is a complete story of a solenoid. Hope you understood this solenoid. Okay, next you just see here. Next you just see here. For example, these are the magnetic lines of force. These are the magnetic lines of force, which is taken as B. Now, I told you yesterday that if any magnetic, charged particle enters with certain velocity exactly perpendicular to the magnetic lines of force, but I explained in a different style. What was the style? Magnetic induction I have taken like this. Okay, magnetic induction I have taken like this. This is B. I told you that if any charged particle enters, it will take a circular motion. I told you or not? Okay, yes. If it enters with velocity v, it takes an anti-clockwise direction circular motion. I told you or not? So this is magnetic lines of force are into the board and perpendicular to the board in this case. But now I am explaining magnetic lines of force are not in this direction. they are in this direction. If any electron enters into the magnetic field perpendicularly, how it moves? Like this it moves. Now here it is moving like this, no? You can see the complete circle like this. But if the magnetic lines of force are like this, a charged particle enters into the magnetic field in this direction, it moves in a circular motion in an anti-clockwise direction like this. Hope you are understanding. Okay. So if the charged particle moves in this direction, what happens with certain velocity? What happens? What happens here? See, magnetic induction here. What is the force? See, I told you here, force F is equal to BVQ sine 90. I told you. Because magnetic lines of force are like this, and I told you the formula is magnetic field is taken as Q into V cross B. Q into V cross B. So V and B. B is like this inside the board. V is like this, making angle 90 degrees. And that's why the force is going to be BVQ. Sin 90 is 1. So formula in this case is just BVQ. Am I right or not? But if the charged particle moves in this direction, V is in this direction, okay, so and B also in the same direction, V is in the same direction, B also in the same direction, then what happens to angle theta? Theta is 0 degrees. See, magnetic field is like this, velocity is like this, BVQ sin 90. If magnetic field is like this, charge also moving parallel to the magnetic field, then what is the formula? Theta is going to be 0. So for any charged particle, B is in this direction. If V is in the same direction, theta is equal to 0 degrees. Then what happens to B? Magnetic field. BVQ sin 0. Sin 0 is going to be 0. No magnetic field will act. No magnetic field will act. Now let us imagine the charged particle is moving in the left direction. Magnetic field is in the right direction. So angle theta is how much? 180 degrees. So here same thing. Force due to magnetic field is BVQ sin 180 is also going to be 0. If particle goes like this, no net magnetic force acts on that. But if the particle goes perpendicularly, then it will take a circular motion. If it goes like this, no circular motion, just as if nothing is acting on that. No net force acts on that. Free వెళ్ళిపోతుంది. Hope you understood what I am saying now. Okay. If this is the situation, the next case is if this is going to be the magnetic field. If this is going to be the magnetic field and now just here, if any charged particle enters, okay, if any charged particle enters with velocity in this direction, not like this, not parallel, not anti-parallel, or not perpendicular, it makes a certain angle with the magnetic field in this direction. This is B and this is V, so angle is going to be theta. Okay, so what happens to velocity? Velocity came out, this is velocity V, this is called as V parallel, and in this direction this is called as V perpendicular. Try to remember this concept what I am explaining now. So in this direction V parallel, velocity is parallel, in this direction this is perpendicular. See, V parallel is going to be V cos theta and V perpendicular is going to be V sin theta. Hope you understand now. Okay, so if the particle enters into the magnetic field with certain angle theta, which is given here by the line like this. For example, if a electron enters in this direction, how does it move? How does it move? See, it moves in a spiral path. Spiral path. What is the meaning of a spiral path? You just see here now. Spiral path means when the particle moves like this, it goes like this. Okay, so previously, if it goes perpendicularly, it takes a perfect circle. Instead of perpendicularly, itla pokundaga koncham cross ka poyindanko, then the circle will be like this. Helical path antunnanu. Okay, so this is called as helix, or it is also called as helical path. Hope you are understanding now. Then what is the formula for radius here? Generally we write the formula as mv by bq. Okay, why mv by bq? Because any charged particle enters with certain velocity, two forces will act. I said, what is this force? Magnetic centrifugal force. In this direction magnetic force, which is BVQ. BVQ sin 90, which is equal to MV square by R, I said, okay. So VV gets cancelled here. VV gets cancelled. From this, I told you yesterday, it is going to be MV by BQ, I told you or not? And this is possible when it enters perpendicular to the magnetic field. But if it enters with certain angle, you shouldn't consider MV now, you have to consider MV perpendicular. MV perpendicular. Therefore, R is going to be MV perpendicular means MV sin theta by BQ. Understood? Angle components will get. Angle components you get. So if this is the situation, okay, if this is the situation, then what is the pitch of the helix? What is going to be the pitch of the helix? Okay, pitch and pitch means the distance between the two parts of the helix. So this is called as pitch. How do you find out the pitch here? Pitch is nothing but, okay, what is the meaning of pitch now? So pitch is nothing but distance x. Okay, so this is distance x, which is called as pitch and okay, so pitch is nothing but distance. Pitch is nothing but distance. Distance means velocity parallel into time, because distance is nothing but velocity time, general formula. But velocity perpendicular is called velocity parallel, you have to consider, because it's moving in this direction with parallel velocity. Okay, so what is this parallel velocity? Therefore, pitch P or pitch x can be taken as V parallel is nothing but V cos theta into time. Time is nothing but 2 pi m by BQ. Understand what I'm saying? I told you yesterday time period. Okay, so what was the time period? How did you get this formula? I told you that if this is a magnetic field, okay, if any charged particle enters into the magnetic field with certain velocity, it is going to take a circular path, I told you. And here I also told you that in this direction force due to magnetic field will act, in this direction centrifugal force will act, both are going to be same. I told this is BVQ sin 90, which is 1, which is MV square by R. Okay, sin 90 is 1, doesn't write, we did not write. This is this one. So R is equal to MV by BQ, I told. Okay, so I have taken V by R separately, which is going to be omega. V R means this is BQ by M. So omega, I got it as BQ by M. But what is omega? Omega is nothing but 2 pi by capital T, which is nothing but BQ by M. So T is equal to 2 pi M by BQ, time period, is the formula. Yesterday I have derived this one. So for that I have taken pitch of the helical path. This is going to be the formula. Understood? Now the last topic which we have to discuss here is, for example, there is a wire, infinitely long wire. There is an infinitely long wire which current passing is I. And here I have taken one wire which is current passing through this is I2, and this is a finite wire having length L. The length of the wire is L. It's a finite wire, a small wire, not an infinite wire. Okay, so what is going to happen now? I told you yesterday that if any current passes through the wire, it creates a magnetic field. Okay, it creates a magnetic field B1, which is nothing but mu naught I by 2 pi R. I told you or not? Huh? Yesterday I told you or not? If for infinitely long wire, actually formula was not this one. Formula was mu naught I by 4 pi R sin theta 1 plus sin theta 1 plus sin theta 2. For infinitely long wire, theta 1, theta 2 was 90. Sin 90 plus sin 90 was 2. So this is 2 here, 2 1 times, 2 times. So mu naught I by 2 pi R for an infinitely long wire. Yesterday we told you or not? And what is this R? R is nothing but the distance between the two wires, which is taken as D here. So okay, so this is the D. So magnetic induction, because the first wire I can consider this as, that was the formula actually. A formula, general formula is mu naught I by 2 pi R, but here he has taken the distance between the two wires is taken as D. So the magnetic induction, because the first infinitely long wire creates a magnetic field surrounding it, explained by Ampere's right hand thumb rule. This is the direction of the current, this is the direction of the magnetic field, and this magnetic field will link with the second wire, and it will drag the second wire. It will attract the second wire with certain force. Okay, it will attract the second wire because magnetic field is created. Understood? And what is the formula for magnetic force? The formula for force is Fm is equal to magnetic induction is Bi, and length of the wire is taken as L. Okay, what is this? Magnetic induction, because the first wire is B1 and the current in the second wire is taken as I2 and the length of the second wire is L. And the angle is taken as sin theta, which is sin 90. Okay, so the magnetic field developed exactly makes 90 degrees. So sin 90 we did not write. Actually, you know, there is a basic formula. Whenever a current passes through the wire, surrounding the wire, magnetic field is developed, that is taken as B, which creates a sudden force of attraction. Whatever it is going, for example, an electron is going, it tries to attract the electron because the wire in which current is passing is acting like a magnet. It tries to drag whatever comes within this magnetic induction. Okay, and the force is given as Fm. Understood? And this magnetic field is taken as B. What is the formula for force due to magnetic field because of a wire? It is just taken as BIL sin theta. Just like for a charged particle, the force due to magnetic field is taken as BVQ sin theta. Single charge BVQ sin theta. A wire consists of millions of charged particles. BIL sin theta. Instead of velocity, current will be there. Instead of charge, L will be there. సో బీవీక్యూ అంటే భార్య ఎందుకని, బీవీ అంటే భార్య, క్యూ అంటే ఎందుకని, బిల్ పెంచడానికి. ఇంట్లో బిల్ పెరుగుతుంది అమౌంట్. ఇప్పుడు అర్థం కాదు, పెళ్లి చేసుకోవడం అనుకో, అప్పుడు తెలుసా ఏం పంచదరాని. అట్లా షాపింగ్ మాల్ తీసుకోవాలా, సినిమాలకు తీసుకోవాలా, షికార్లకు తీసుకోవాలా, ఊగుకే తిప్పాలా, బండి పెట్రోలు ఖర్చు, లిప్స్టిక్లు, పౌడర్లు, కాస్మెటిక్స్, చాలా ఎక్కువ ఖర్చు ఉంటుంది వాళ్ళకి. అర్థమైందా? ఇదంతా చెప్పేది టైంపాస్ కోసం కాదు, గుర్తుపెట్టుకోవడానికి. BVQ, BIL, బిల్. సింపుల్ వే టు అండర్స్టాండ్, రిమెంబర్. మీరు అట్లా చేస్తారని కాదు, మీరు మంచి పిల్లలు, మీరేం ఖర్చు చేయరు, ఇంకా మీరే సంపాదించి మీరే తెచ్చిస్తారు. డాక్టర్లు కదా కాబోయే డాక్టర్, భార్యాభర్తలు ఇద్దరు డాక్టర్లు అవుతారు. నువ్వు డాక్టర్ అయితే ఆయన కూడా డాక్టర్ అవుతారు. ఏమంటారు? అట్లేం లేదా? Hope you're understanding what I'm saying now. So this is the formula. So therefore I got the formula C. Why I did write B1? Because the magnetic field developed because of the first wire is taken as B1, and I am talking about the magnetic field developed on this wire which tries to attract. So because of the second wire, Fm, force due to magnetic field is B1, and the current is passing to the second wire is taken as I2, and the length of the second wire is taken as L. Only B is coming from the first wire, remaining things are from the second wire. So if I just combine these all, B1 is taken as mu1 and this is I1. So mu naught I1 by 2 pi d I2 into L. This is going to be the formula. What is this? This is going to be the formula for parallel lines through which the current is passing. Understand what I am saying? Okay, so this is the formula. Force due to magnetic field because of two parallel wires, and when the current moves in the same direction, then what happens? There is an attraction. Force of attraction is there. If the current here, if it moves in the opposite direction, there is a force of repulsion. Here, if the current moves and like this, repulsion will be there. If the current is in the same direction, attraction is there. Okay, why is it so? I'll tell you. See, this is current is moving in this direction. No? So I'll thumb goes like this, four fingers come like this. Am I right or not? Thumb goes like this, four fingers comes like this. Okay, for this wire, thumb goes like this, four fingers comes like this. So ఇది ఇట్లా పోతుంది, ఇది ఇట్లా వస్తుంది, రెండు ఇట్లా కలుస్తా లేదా? ఇప్పుడు ఫర్ ఎగ్జాంపుల్ దిస్ ఇస్ ద thumb and the four fingers are coming like this. At the middle I am saying no, in the middle, in this gap. So force, these four fingers will come like this. But for here it goes like this. ఇక్కడ నుంచి ఇట్లా వస్తుంది, ఇక్కడ నుంచి ఇట్లా వస్తుంది, బాండ్ స్ట్రాంగ్ ఫామ్ అవుతుంది, అట్రాక్షన్ will be there. If it is going like this, in this direction is going like this, so it is coming like this, and this is going in the opposite direction, so there is a repulsion. Repulsion will be there. So attraction means current should be same direction. Ippudu varaku same poles repel, same poles repel, same charges repel, but here same direction current attracts, completely different. Understood what I am saying now? Is it okay? So this is the last concept of this chapter. Understood? That's it. You can do any problem based on this. Very simple. Okay. Now, one more simple concept is left here. What is that? For example, you have taken one wire of, okay, you have taken one wire of length L, and you have taken in the form of a circle, then what is this? This is having a circumference 2 pi r. 2 pi r, only one turn. And what is the formula for magnetic induction? B mu naught I by 2r, which r is taken as radius. Okay, I have taken the same wire now. I have taken the same wire, but instead of taking one round, I have taken n equal to 4 turns. ఇదే వైపు ఒకసారి చుట్టకుండా చిన్న సర్కిల్స్ లో 4 సార్లు చుట్టాం. Then what happens to the magnetic induction? Will it increase? Will it decrease, or what happens? Let us see here now. What is going to happen? Let us see. So here number of turns in the first case is only one turn. In the second case, the number of turns is taken as 4 turns. Understood what I am saying now? So what do you understand from this? See, the same formula will be there, only n will be added extra. So the formula will become B is equal to mu naught Ni by 2r, where n is said to be number of turns. Inni salu chuttinadu anedi number of turns. Understood what I am saying now? Okay. So here the length is same. For this same length, I have wound only one time. Only one time. So I will take this as radius r1. This I will take it as radius r2. Okay. What is the radius here? R2. Here radius is r1. So I take it as 2 pi r1. The same thing is wound how many times? N2 times. And what is that N2? We don't know. Let us take this as L1 is equal to N1 2 pi R1, and if I take this here, I will take it as N2 2 pi R2. So 2 pi gets cancelled. Therefore N1 R1 is equal to N2 R2. N1 R1 is equal to N2 R2. What do you understand from this? See, I can take here R1 by R2 is equal to N2 by N1. R1 by R2 is equal to N2 by N1. So what do you understand from this complete concept here? What do you understand from this complete concept here? You just see. See, B2 by B1 is equal to, see, as the formula is B is equal to mu naught Ni by 2r, B is directly proportional to N, inversely proportional to R. So B2 by B1 is equal to N2 by N1 into R1 by R2. Because this is inverse relation, no? So what do you understand from this? B2 by B1 is equal to N2 by N1. N2 by N1. Instead of R1 by R2, can I write it as N2 by N1? So therefore, B2 by B1 is equal to N2 square by N1 square. Understood? Where N1 is equal to 1 turn. Where N1 is equal to 1 turn. Therefore, B2 can be taken as N2 square by 1 square and 1a, which is nothing but B1. Is it understood? So B2. For example, the magnetic induction because of this is 2 Tesla. Tesla is the unit of magnetic induction. So what is the magnetic induction? If the same wire is wound 4 times. 4 times. So your magnetic induction for this is going to become B2 is equal to N2 square times of B1. N is 4. 4 square into B1. B1 is how much? 2. 4 4 is 16. 16 2 is 32 Tesla. Idhe wire 1 turn, if you take 2 Tesla, idhe wire if you turn into 4 times, then what happens? Previously, if B1 is 2 Tesla for 1 turn, then if you take the same wire and turn and take to 4 turns, the magnetic induction becomes N square times of B1. Hope you are understanding what I am saying now. Okay.